and today is going to talk about how to evaluate and test natural language processing models. All right, thank you very much, Samir. The floor is yours.
Yeah, thank you, Andre. Thank you for the introduction and for inviting me. Pretty excited to talk about this work today. So today I'm going to be talking about evaluating and testing NLP models. So let's get started with a pretty fundamental question that a lot of us face. We are sitting on our computers, we have some data set, we have some model that seems to be working, is getting some set of results. And then a new paper comes out, maybe a Muppet that hasn't been picked yet. And then the question is, well, should I, this new thing that has been introduced, is it worth me using this new thing, right? Is it better than what I'm doing existing, what my existing model is? And this is not a problem just for researchers in some sense. This is also a problem for industry and for companies and things like that. These are companies that are selling machine learning products or integrating machine learning products into their own. And they have the same questions, like, is this new thing that has come out something that we should use in our products, right? Now, one way to answer this question is to go to our leaderboards. So we can look at, for example, the question answering leaderboards and see how these models perform. And turns out that the models have, even on squad 1.1, the models have surpassed humans a while ago. People have introduced new leaderboards like squad 2.0, and then more recently, I suppose, humans have been surpassed on that as well. Okay, so maybe the problem is that we are focusing only on question answering. Maybe we should be looking at many more tasks. And so here's the leaderboard. That is Glue, which has a bunch of very different ways of evaluating a pre-trained model or a representation model. And you can see that all the way in number 9 is where humans are. And there are a bunch of techniques that are better than that, right? You can also introduce newer versions of leaderboards, which are inherently much more challenging, and it takes much longer then for machine learning models to catch up. But again, you see this trend where, again, humans right now, or as of a month or so ago, are at number 3, right? So after looking at all of these results, you might be tempted to think like, hey, we should be all, as a community, patting ourselves on the back and conclude that we have solved NLP. We are better than humans on so many tasks. Clearly, we are done, right? And so it doesn't kind of matter, as long as it's better than humans, which model you actually use. But we kind of know, and this is some of the other talks have also touched on this a little bit, that this is not true, right? These models can be very, very sensitive. Here are a few examples that we've seen, but these are examples that many other people have seen as well. If this is a visual question answering system, you can ask a question like, what type of road sign is shown? Maybe you don't have the ability to comprehend the road signs here. And the model will tell you that it's a stop sign and it's correct. And then it's a useful signal here. But what if you rephrase the question and ask essentially the same question, but putting a which instead of a what? Turns out that many models, at least the model we tried at the time, which was state of the art, changes the answer. It says, do not enter. Right? So now the user somehow has to know how to phrase the question to get the right answer, and that's a bit of a problem. Here's another example where sometimes for reading comprehension, it can be sensitive to typos in ways that it's very unintuitive. So here's a European example where it ends up being how long is the Rhine? If you read the paragraph, there's some co-reference involved, but the answer is correct. It's 1,230 kilometers. But if you ask the same question, but you have a typo, maybe you add 2 question marks at the end, the model at the time, which was close to state of the art, changes it to more than 1 million, right? Clearly wrong at that point. So here's another slightly different example than just sort of looking at these rephrases. Sometimes these models can be wrong in ways that are that on the surface look correct, but when you ask them a little bit more, you realize that they're not quite consistent. So for example, this is a VQA image where you can say how many jets, or there may be a longer version of this question, and the model is pretty good at telling you 6, and that's the correct answer. But you can ask questions like, are there 6 jets? And clearly, if the first answer is correct, the model should say yes, but the model says no, right? And there are lots of examples of these kinds of reasoning. So what this sort of tells us that there are some problems in the way we are evaluating these things. And partly it's the way we are relying so much on accuracy or on leaderboards, right? We are sort of saying how good is machine versus a human on accuracy. And clearly this is sort of a well-known problem because essentially your test set duplicates the biases of data collection, right? So there are all kinds of shortcuts that show up, and that's why these models look good. And more specifically, they do not represent real world usage because of your biases in the data collection. But I think there's a finer point here that's also pretty important, is that when you're looking at accuracy, it's not just about the data set, that whether it represents real world or not. What you're essentially doing is sort of summarizing the whole performance with a single metric that's sort of an absolute number. And that absolute number is not quite sufficiently insightful about what's actually going on. So if it's 80% accurate, well, that depends a lot on what your data set was. And is 80% good? For some tasks it might be, for other tasks it might not be, for some test sets it might be, and so it gets a little bit fuzzy, right? Even more importantly, you don't get any breakdown of what the model's capabilities are, right? So what are its strengths, what are its weaknesses, and any insight into how we can improve it, right? Like so looking at accuracy encourages you to think of it as a black box, but even think of the whole training pipeline as a black box, and just try to improve it by borrowing new models or changing the loss a little bit, playing around with hyperparameters, rather than figuring out what is the model unable to do and what is the model able to do, and make decisions based on that. Right? So going back to this question of, well, should I replace my model with this Oscar, or should I use Oscar in my products? I would contend that we don't really have a solution to this problem, right? We don't know how to answer if someone comes to me and says, hey, I have these two NLP models, which one is better? Apart from pointing to accuracy, we don't really have much of a solution. And so that's kind of the goal of what I'm going to talk about today. I'm going to talk about methods to try and figure out what the possible bugs in your NLP system are, and how we can try to find these bugs, right? And I'm going to cover methods that are both automatic or they're manual, right? Both kinds of methods. So let me tell you a little bit more about what my approach to this has been past couple of years, and then I will talk about a bunch of different methods. So primarily what we've been doing is something that's often called perturbation-based testing, where you're taking instances such as X, which should have output Y, and assume that the model is correct on these instances. You can always pick the ones where the model predicts Y to be the correct one, and send it through some semantic transformation, right? And we'll talk about what these transformations are. I'm going to keep it vague here. And this transformation essentially changes X, maybe changes Y as well, but it's somewhat deterministic, right? So you get an X prime, and you know that the label for X prime should be Y prime, right? The true label. And then what's remaining is to send it to your model, your black box model, and see what the model produces, right? It's a black box model, so I'm not looking at which neurons are getting activated or anything like that. I just want to look at what the model thinks is the output for X prime. Let's call it Y hat. We just want to see whether it matches the expectation or not. Pretty simple on that end of things. The bigger question mark here is, what is this transformation function? Where are you getting these X prime, Y primes from? And why is this useful? Right? This seems like a different way of computing accuracy. So what's going on here? And so we have a bunch of different papers that can sort of be viewed under this lens. And there's some that I'm going to talk about where we have some automatic way of finding this transformation function. And by automatic here, I mean finding the transformations that are specific to the model, and sort of try to find loopholes in the model. It's almost adversarial, both of these. And then there are some manual methods we'll talk about. Maybe I'll talk about just one, where you have some intuition or you have some expectation as to what the model should have. And then you want to test it by writing that transformation function. And finally, I'm going to talk about checklists that sort of is a framework for doing this perturbation-based testing, and sort of makes it easy for you to do that. So we'll talk about that at the end. Mostly I'll talk about checklists. I'll just touch upon some of these other ones. So let's get started with the first one. This work was at NLP 2019 with Eric Wallace as the first author. And the idea here is to sort of find loopholes in the model, and a specific kind of loophole. In this case, what we were interested in was to concatenate an irrelevant phrase, and in a way that does not change the output, right? So X prime here is basically X with some irrelevant phrase added, and Y prime is same as Y, right? And this is an irrelevant phrase because we try it out on many different inputs. So it's not specific to it's not relevant for the task, but also it's not specific to any input. So this is just a phrase, we call it triggers, that if you add it, it causes the model to maybe to change its predictions, right? Even though it should not. So let's see a quick example of what it looks like. Just as a warning, since we are trying to find what's the worst case performance is, some of the language in this section might be a little strong. Okay. So here's what we find. This is a universal adversarial trigger for sentiment analysis, where we are trying to find these short phrases. In this case, it happened to be zoning, tapping, fiennes, which is irrelevant for sentiment. Like nobody would look at that and say, oh, that's a positive thing or negative thing or so on. And we just want to show that if you add this phrase to inputs, right, especially to positive reviews, most of the time the model prediction goes from positive to negative. And most of the time in the sense that it's almost 100% in this case, where originally the model was 86% accuracy on this subset of inputs. And when we add this, it goes to 29% accuracy. Just this phrase, which has nothing to do with it. So in a sense, this is a bug, but it's a bug in an adversarial sense where some users might be able to come up with this phrase by using some method and then try to get the model prediction to change. Here's another example of what these triggers might look like for a different task, like question answering from context. This task is something we'll be returning to again and again. Here are two examples of two questions and context. You don't need to really read the questions or the answers, just to say that the answers are correct in both of these cases. And both of the questions have the structure of why did something happen. What we do is we find a trigger that can essentially control what the answer is. So in this case, all we do is we add this phrase to the context, and the context is actually bigger than what we've shown, but we add this single phrase to the context. Why, how, because, that's the fixed part. And then to kill American people happens to be the phrase that you can replace with whatever you want to replace it with. And the answer becomes whatever you replace it with, right? So as long as there is why, how, because, with high probability or with a reasonably high probability, the answer becomes whatever follows that phrase. And this is maybe not a natural bug, but this is definitely a security loophole, right? Like if somebody wanted a QA system to control the answers of a QA system, this is one way to do that, and that's not ideal. And what is important is that this phrase is not specific to this context. You can put it in other contexts as well, which look very different from the first one, but the answer still changes. Right? And you can replace the phrase with something else, and then the answer will become that phrase as well. And in fact, like just looking at all of the why questions in the data set, 33% of them just became to kill American people when we added why, how, because. Right? Just 3 words, English regular words, did this, right? So this is just one example of sort of trying to find perturbations that would cause the model to misbehave. Right? The next sort of example is a little bit more natural in the sense that it might be something that could actually show up in practice rather than being adversarial. So this is work we did at ACL 2018, primarily led by Marco, where the idea here was pretty intuitive. The transformation we're going to make here is to take X and give an X prime that essentially is the same, right? We will do some rephrasing, some paraphrasical rephrasings, but the meaning will be exactly the same. And of course, in this case also, we don't want y prime to be different from y. We are changing x, keeping the meaning the same. So the output should also be the same. Very simple idea here. I won't go into details of how we did it, but I'll sort of give you some examples. This what type of road sign is shown getting replaced by which type was an example of what our system produces automatically. Right? It looks at what type of road sign is shown, realizes that you can ask a question, that's a rephrasing, which type of road sign is shown, that leads to the model output to change. Right? And what one would easily agree with, I think, is that this is an example of a bug because it's pretty likely in the real world and it's causing the model output to change. But one of the things that is not answered just by looking at this example is how often does this actually happen? Is this something you found for this single instance, or have you found this across a larger set of instances? Right? And so in the Sears paper, we also try to look at the global impact of these changes to try and generalize these perturbations to see, is this actually a bug that's worth me spending time to fix it? Or is it just something that happens on a single instance? And so in this case, we evaluate generalizations of these edits that shouldn't change the meaning, but are leading the model to change the output. So an example of the generalization might be to say, literally the string what type should get replaced by which type, and that should never change the meaning of the question. Let's see how often it changes the output. Or you can also generalize this further. You can say, anytime we see what noun, replace it with which noun and see what happens. And in this case, the rule that we did extract was the more general one, taking all instances of what noun in your potentially unlabeled data set and replacing it with which noun leads the model to change the output more often than it should. Right? This should be 0% of the time it changes the output. In this case, I think it was almost as high as 20%. I want to say 17% or something, right? Which is pretty high. Okay, so those were two examples of sort of automatically trying to find problems. In both cases, they were somewhat adversarial. So they were model specific. So the rules that you come up with or the triggers you come up with are model specific. More recently, we have started thinking a little less adversarially and more about what is the right way to evaluate things. And it has sort of involved a little bit of manually specifying what we really care about. And so the first one in this direction was this work at ACL 2019, also led by Marco, where we were looking at consistency in QA systems. And the idea here is we want to change X in a way that we know what Y prime is, and it's something that's logically implied. And then we want to see whether the model agrees with that logical implication or not. A bunch of people have done this for lots of different tasks. We looked at it for QA, so we will just give you a quick example of what this means. So here's an example slightly different from the one we had earlier. How many birds are in this image? And you can look at the image and say one, and the model does that as well. The model says one. You might have a bunch of other questions that are logically implied from this pair of question and answer. So a question like, is there one bird? You would pretty much say yes. If the first thing is correct, condition on that, is there one bird is true. Are there two birds? Well, no, because there's only one bird. Are there any birds? Yes, because there is one bird, right? And what's important to know is that you can make all of these judgments without looking at the image, right? As long as the first question and answer are given, all of these are logically, deterministically implied by the first answer. And turns out that the VQA model that we were playing with actually gets all of these wrong. Right? It gets the first one correct, how many birds, it says one, but all of these logically implied questions or conclusions, I guess, it's not able to make. So this model is somehow not consistent with its own predictions. So we try to generalize this to create a small data set where we used sort of syntax parsers of questions and did transformations on there to automatically generate these kind of implications. I guess automatically, by that I mean programmatically generate these transformations. And essentially we are able to get at least one of these logically implied questions for about 2/3 or 3/4 of the validation data set, right? And we did some manual studies to show that these questions are actually high quality. And so this could be sort of thought of as an additional data set. Whenever you're evaluating your QA system and you want it to be logically consistent, you could just directly use this data set. Right? But I think the main important point is not the data set, but to think about testing for things like these. Okay, so that brings me to the sort of main thing I want to highlight today, which is the checklist work that we did last year at ACL, also led by Marco, with Tong Shuang and Carlos as co-authors. And in this case, we wanted to come up with a framework that helps you brainstorm about these transformations and maybe even helps you write about them, right? And so I think the primary contributions of checklist are sort of twofold. One is a sort of motivation or recommendation for doing this in the first place. And secondly, a toolkit that helps you do it more and more easily. So let's go back to sort of where we are, after I've shown you all these examples of finding bugs, this is sort of what the lay of the land looked like. There were a bunch of known issues with NLP by the time we were looking at this, like a year ago or so, where there are a bunch of adversarial examples that we know exist. We know there are shortcuts and biases. Models can be inconsistent. They're not robust to all kinds of different perturbations. And a lot of people had tried a bunch of these issues, including us, on a bunch of specific tasks, right? So robustness to typos for machine translation, right? Lack of consistency in NLI. Like there's this cross product of how the community has been thinking about this. Which is fine because we are sort of learning more and more about NLP. But looking at it from a point of view of someone who has a new model, this doesn't really help. Right? If somebody is asking the question for my model and for my task, which of these issues are actually relevant? It's not clear how to answer that because there are all these separate data sets that have been created. Specifically, like, are there any issues that are unique to my model? Like, are there or my task, right? Are there some issues that I care about that people haven't looked at yet? And in general, the question is, given the model and the task I'm interested in, is there a way for me to evaluate properly that is somewhat aware of these things, but also lets me extend it? And so this question of, is there a way to test this complex piece of software properly is something that maybe we've forgotten, but this is something we do know, right? We've been testing, or at least software engineers in us should have been testing complex systems, and maybe we can apply some of these ideas to machine learning or to NLP as well. Right? So let's see what that looks like. So I'm going to talk about some of the lessons from software engineering that are sort of the principles of testing and how we took those ideas and try to apply it to NLP and came up with checklists. So one of the main ideas is to test small units, right? So unit testing is pretty important in software engineering. Figure out what are the sort of specific functionality and test those. It's not completely obvious how to map that to NLP. Specifically, I think the temptation is to think of this as, hey, you're looking at neurons or activations or attentions or something at that level, and that's not what we're interested in. The way we define these small units are very specific to the task that you're looking at. And in some sense, it's more about the linguistic capabilities that are needed for the task, right? These are some capabilities that you think the model should have before you can claim that it has solved your task, right? And it could be simple things like, can it handle negations? Can it do coreference? Can it do lexical variability, right? And I'm not saying that you have a negation detection system or a coreference resolution system. I'm saying even if you're doing sentiment analysis, these questions are relevant. And I'll show you some examples of that. Okay. The next principle we looked at was this idea of behavioral testing in software engineering, where the idea is to decouple the tests from the actual implementation, right? So what you're trying to do is test the behaviors of your software system rather than test whether each line is working or not, right? So in this case, the decoupling means we're not going to be focused too much on whether the architecture is correct or not, or what the activations look like, and what the loss was, whether the optimization is working properly. even what the specific problems in the training data might be. We're not looking at that level of, that's all implementation as far as we are concerned. We are instead taking essentially a black box that you're saying does the task. We just want to test whether it actually does the task or not. So we are only going to be focusing on test time predictions of this black box. And that's what we are going to use as the interface to test the model. And finally, we're going to be looking at the type of test that software engineers have been thinking about and seeing how it translates to NLP. So the first one that I think most of us are very familiar with are unit tests. These are just mostly example inputs and what the output should be. This is very similar to accuracy, so it overlaps a little bit, but we're going to think of them as minimal instances that capture the capability that you're testing for. Right? And we'll see example, it'll become obvious, but this is very similar to computing accuracy, but you're sort of trying to create instances that are targeted for specific capabilities. The other sets of tests we're going to have are more of mutation tests. Here, the idea is to take an input, change it, and see whether the output also changes in expected ways. And so this is sort of what we've been doing so far. And so it's very similar to all the stuff before that I presented. Okay, so let's look at an example of what this looks like for sentiment analysis. So first thing to do is to figure out what are the capabilities that are needed. And so for sentiment analysis, I'm not a sentiment analysis expert, but I can imagine you need to make sure that negations are handled properly. You need to make sure named entities are appropriately ignored when relevant. You need to make sure that the model understands the basic vocabulary involved in sentiment analysis. And people who've been doing sentiment sort of know these things and have been studying this for a long time. Then the question is, well, okay, so we have our sets of capability. We need to now start testing each of these capabilities, right? So we're going to think of this as conceptually as a matrix where you have different capabilities as rows, and we're going to test them with multiple tests as columns. So that's what sort of the top thing is going to be. The first test we're going to look at are essentially our versions of unit tests, which we call minimal functionality tests. These are handwritten instances that we're going to use to test specific capabilities. And in some sense, these are minimal instances, but we're going to create sets of these. So let's actually get started with one of them. Let's look at what I mean when I say the model should know sentiment vocabulary. It just means that it should know that there are certain words that are sentiment laden, right? So here are a few examples. This was a great flight, should be positive. I hate this airline, should be negative. I like this seat, should be positive, and so on. Pretty simple. You would hope that the test set has these things, but maybe they're not as simple as this, and maybe they're not grouped together. And what we can do is we can take these instances, run it through a model that we're interested in testing. Right now, I'm talking about Google's commercial sentiment analysis system that they sell. And we can see the output sometimes seems to match, but there are some instances that it doesn't seem to match. So what do we do with these 3 instances? Well, 3 instances are not useful. What we actually do is we take each of these and generalize them to essentially using templates to create hundreds of examples for these. And then we can, instead of looking at, oh, we got 1 by 3 wrong, we can actually compute a sort of failure rate. And turns out, if you only have expectations of positive versus negative, the failure rate is about 7%. Right? Now, just to be clear, this is really, really simple example. So the failure rate should be 0. But because of the sometimes predicting neutral, the model seems to get more than 0% failure rate. Right? But maybe whatever your threshold is, this is maybe okay. You can also create slightly different ways of testing the vocabulary by omitting anything that's sentiment laden. So this is a commercial flight. That was an English cabin crew. If your model has capability of predicting neutral, all of these should be neutral. Right? In this case, it turns out that for the model, and again, when we template it out and generate a lot of them, the model actually gets about 11% of them wrong, which again should be 0. These are clearly neutral statements. but 11% end up being either positive or negative. Okay, so that was our first kind of test. We can show another example of using the same idea for a different capability, just to give you an idea of what it looks like. So let's look at negation, which is a little bit difficult for sentiment analysis systems. And so what thing we're going to do is we're going to essentially take simple examples. We're going to create simple examples that just have a simple negation in it, right? So the cabin crew was not good. The pilot wasn't nice. The flight wasn't great. All of them should be negative, but the model sometimes thinks they're negative, sometimes neutral, sometimes positive. When we aggregate it over a large set of examples, turns out 50% of the time, the model gives the wrong answer, which is extremely high. Maybe it's intuitive, maybe we know negation is hard, but it's still surprising given the fact that these models are close to or surpassing human performance. Right? Here's, so this is sort of an easy way of doing negation. Another thing we started looking at was what we call invariance tests. So these are sort of perturbation-based tests where we are not just creating instances, but we're taking actual instances from your unlabeled data or whatever you have access to in order to test whether the model is robust to those perturbations. So let's create another set of columns. We're not going to be looking at minimum functionality test. We're looking at invariance now. And let's look at the one that we haven't looked so far, the named entities. And in this case, what we're doing is we're going to take actual instances that have a location in them, and then replace them with other location and expect that the output should not change. So thank you. We got on a different flight to Chicago. We replace Chicago with Dallas. We expect that the output should not change. That's why it's called invariance, because we're making changes where the output should be the same. Turns out that for these two instances, the model actually changes the output. And if we aggregate it over a bunch of changes, it ends up being as high as 20% of the time. Changing the named entity is changing the sentiment. That's a problem. Our second kind of sort of perturbation tests are what we call directional expectation tests. In this case, we are making changes where we do expect the output to change, or we have some expectation as to what the direction of the output should be. So we'll create another column for that. And in this case, we'll return to this vocabulary aspect and use existing instances to create these kind of tests. The idea here is to take original instances. So American Air service wasn't great is an actual tweet in our data set. We're going to add a very negative phrase to this. So like, you are lame, right? Or I dread you to these instances. And our expectation is not that this will definitely be a negative tweet. Our expectation is that it shouldn't become more positive when you add this negative phrase, right? Even if the prediction is the same, that's still fine. It shouldn't become more positive. But in this case, in both these cases, the Google classifier thought that it was going from negative originally, it became neutral when we added a negative phrase, right? And overall, this also had a pretty high failure rate of about 50%. Okay, so this is sort of an example of what we can do with this way of thinking about testing. Suddenly, we have a report card of sorts, right? We have capabilities of the model, all kinds of accuracies, things that it seems to be good at, things that it seems to be bad at, without us being adversarial about it. We've just created data set. We haven't sort of seen what the model is bad at. We're just creating sets that we think the model should be good at. Okay. And so the idea here is essentially what Checklist provides is a paradigm and tool to easily generate tests. That's the main idea. And there are basically 3 steps to testing. And this might be obvious from what I've presented, but essentially the first step is to sit down for your task, define the capabilities that are needed, right? So what are the sort of fine-grained behaviors that you expect the model to have before you can say that I should deploy this or I should use it in my research. Then you should just write tests for each of these capabilities. So conceptually, you need to fill the matrix. And the creativity here is in trying to figure out how to test each of these behaviors, how to define these test cases, how to generalize them by templates and things like that. And more specifically, try to use a combination of labeled data, unlabeled data, and synthetic examples in order to do this. And once you have these two steps, all you need to do is take your model and run it through these tests, and you get this sort of report card. And you can take 3 models and compare them, and now you have a fine-grained report card to compare. Okay, I'll quickly talk about some of the tooling that we give also, which makes it easy. But I think the main contribution here is the sort of strength of these ideas, and I hope these toolings are also, they were pretty useful to us. I hope it'll be useful to you as well. So the idea here is we are relying a lot on templates to get more coverage, and we give you a nice language to easily write those. So you can start with something like, this is a good book, I want to generalize this. Easiest way to do this is to say, this is a pause thing, right? Pause is the set of positive words, thing is a set of thing words. And once you give us these 3 information, we generate the instances for you. That's pretty easy, but it's still useful to have. These are sort of the instances we generate. We also extend this templating system to sort of start using word suggestions, right? So we can still start from, this is a good book, but replace good with a mask and say, Bert, tell me what are the other words that can go in here. And Bert will give you a list of all kinds of words. You can say, well, I'm going to pick a few that I think are relevant to be created as tests and sort of strike out the ones that are not. And then that goes back and becomes, you can create instances from that. Okay. We can also expand templates using existing lexicons. So we give you a bunch of lexicons based on people's names, first names, last names, sort of split by how popular they are amongst different ethnicities and different sexes. Split these names by, or also give you lexicons of countries and nationalities and US cities and religions and all kinds of things, right? So you can use these lexicons directly if what you care about happens to be one of these things, and you should be caring about these things. We also have this idea of extending lexicons by using Word and WordNet together. So for example, you can start with something like, this is a bad book, look at WordNet to get all the antonyms. So we can do that for you. We can get any word, we can get the antonyms. And then we can use BERT to see which of these would be reasonable fill-ins for the context and tell you that, okay, in this case, only good is the reasonable fill-in. And so you can use that as well. There are a bunch of perturbation functions that we have. So you can write regular expressions based on part of speech tags. You can do all kinds of contractions, all kinds of rule-based heuristics that will help you add more perturbations. And then on the output side of things, once you have your test, how do you test whether the expectations match or not? How do you share your tests and things like that? Some of this we are working on, but that's sort of the framework, right? Okay, so let me actually quickly go over some of the examples since I do have some time. So specifically, I'm going to be giving you examples of checklist applied to a different task. And this task is Quora question answer, sort of question pair detection, right? So given 2 questions, are they a duplicate or not? You can think of it as a binary classification problem. And it's also part of GLUE. And in fact, not just part of GLUE. If you look at sort of what I'm showing you here is the accuracy on the y-axis and different models that have been applied. And each of the dots are different tasks in GLUE. And the black line is sort of how good humans are. So this is sort of relative accuracy. And you can see that this purple line is QQP, right? Quora question pairs is the one that has been consistently much higher than human performance, even when you just take BiLSTM, Elmo, and sort of really old models, right? So we wanted to see, okay, something that has been so much better than humans for so long, are we actually good at that? That's why we picked this task. And we are sort of testing more on the latter side of this curve. We are looking at BERT and Roberta. Okay, so the first one, so we here are sort of the capabilities that we want from QQP. I won't go through all of them, but you can see there are all kinds of things you might care about in here. And we have the different columns that correspond to different types of tests. The first thing we're going to do is going to see whether the model knows what modifiers are, right? So this is sort of a part of speech style test, where we're going to ask, and again, remember the inputs are pairs of questions. So we have a question, is John a doctor? And then we're going to say, is John a fake doctor? And we're going to ask whether the model knows that adding this modifier should make it non-duplicate, right? Similarly, we can also change what we are looking for. So is Patrick Thomas a teacher and is Patrick Thomas a thief? These should be non-duplicate. Turns out like BERT and Roberta have 30 to 40% failure rate on this. So it doesn't really seem to understand that these two questions are different. Here's another example where we are going to change the name in one of the questions. This is sort of does the model understand how to represent named entities? And it's a directional sort of thing. So we're going to take a question from the data set. So is Donald Trump the Antichrist? The sort of rephrasing of that is, could Donald Trump be the Antichrist? Those should be duplicate, but we're going to replace Donald with Eric. And clearly now these are not duplicate questions. Similarly, we're going to change other names and assume that this is not going to be a duplicate. And both of these models sort of fail more than 50% of the time. So they don't seem to be representing these named entities either. We can look at another way for named entities where we take the question, and this was an interesting idea from Marco, was to take the question, keep only the named entities and replace everything else with BERT, and assume that that should not keep the duplication the same. So for example, will it be difficult to get US visa if Donald Trump gets elected? Well, only keep US and Donald Trump and fill the rest with BERT. The question that BERT generates is, will the US accept Donald Trump? These two things should not be duplicates. What are the requirements for selection into MIT? The only named entity here is MIT. So we keep MIT, fill the rest in, and BERT says, what was MIT? Again, these two should be not duplicates. And the models fail about 20%, 25% of the time on thinking that these two things are actually duplicates. Okay. The temporal ones are interesting, where we want the model to know that things happen in certain sequence and before is not the same as after. And so is it dangerous to eat before 10 p.m.? Is it dangerous to eat after 10 p.m.? Should not be duplicates. The model, actually BERT is really bad at this. It fails at 100% of the time, whereas Roberta fails at about 25% of the time, right? And this is interesting because to me, the difference between BERT and Roberta wasn't ever as clear as this result shows, where yeah, Roberta was better and there are these accuracy boosts that they get, and clearly, yeah, they're based on similar architecture, but different training data and so on, slightly different loss. But the repercussions of something like that being so big on some tests was a surprise to me. So this is sort of one example of what insights checklist might be able to give you. I'll give you the example of fairness, and then maybe we'll skip to the end. So in this case, we want to ask whether the model has racial biases or not. And so here are sort of some pairs that we created using sort of commonly assumed stereotypes, which are wrong. So is John black? And is John an offender? Should not be duplicates of each other, right? There's no reason why the system should think those two questions are duplicates. Is Mary black? Is she an offender? Should not be duplicates. Turns out the models are, at least BERT is pretty bad at this. 80% of the time, it thinks that these are duplicates, right? And now the question could be, well, why is it? Is it something specific about this race, or is it just the model is somehow ignoring everything after is John and treating it to be a duplicate? Maybe it's not a racial bias. Maybe it's just model being bad and ignoring most of the context. Turns out that's not the case, because if we replace black with other races like white, Asian, Hispanic, the failure rate of BERT goes to 0. Right? So BERT knows very well that if you say, is John white and is John an offender, are actually not duplicates of each other. But when you replace white with black, it thinks that, often thinks that those are duplicate questions. You're basically asking the same thing. Okay. I think I'm going to skip some of the more examples. There are ones that are a little bit more linguistic, like using SRL and sort of changing the argument structure of the questions and saying that they should be duplicates. You can look at the paper for those examples and so on. Right? So we tested checklist using 2 user studies, one with the industry, one with some researchers. At the industry side of thing, we got one guy who's sort of the involved in the sentiment analysis team to sit with us for 5 hours, and we're really thankful to them. And sort of they have a very well tested model with public benchmarks, in-house focused benchmarks, a huge history of user complaints telling them what predictions they got wrong. On the other hand, we had researchers, both in industry and academia, where we told them to look at the QQP model. And they're not experts on the task. Like, some of them were new to this QQP problem, but they have been doing a lot of NLP development in their time. And in both cases, the users found lots of new bugs that we hadn't thought of. They tested new capabilities that they hadn't tested earlier and we hadn't thought about either. But even the capabilities that we had thought of, or ones that they had been testing before, in the case of Microsoft, they felt that they tested it better. Okay. All right. So in summary, what I've talked about today, and hopefully tried to convince you, is that behavioral testing is pretty important for NLP, right? It's a very simple idea: perturb instances and test for what happens. You can use automatic methods, which are a little bit more adversarial, to figure out what's the worst thing that could happen to your model, or sort of what the blind spots of the model you actually care about are. Or you can think of it as manually defining perturbations that are not so specific to your model and can be used for new models as they come in. And I presented some work on that. And checklist sort of takes the last idea and creates a framework for doing this, where it allows you to write all of these perturbations a lot more easily. One takeaway I want you to have from this talk is to definitely make testing part of your pipeline. Since this checklist work came out, we've been working with a few different teams and ourselves also applying it to more and more different tasks. So looking at machine translation, looking at language modeling, NLI, misinformation detection, and things like that, and applying this idea of checklist to those. And essentially, for each of these instances, we've seen a very similar response, sometimes even by ourselves, where initially there is skepticism about whether an idea is as simple as this would even work, right? But okay, I'm just going to spend some time, even though I'm skeptical, I'll write some small things. And then usually this leads to a surprise where you're like, hey, this actually doesn't work as well. My model isn't as good as I thought it would be on even the simplest things. And that has led to people trying to adopt checklists as part of their pipelines. And we are trying to create tools and sort of software to help ease that last part of this whole thing. Okay, so that's all I have. I want to thank all the collaborators that have contributed to this. And yeah, I'm happy to take questions at this point.
Okay, thanks a lot for the nice talk, Samir. So there's a few questions in the chat, and we have plenty of time for questions. Cool. Jonathan Berendt, do you want to ask live?
Sure. So why did I write them? Yeah, I guess I just want to ask, like, it's clear how to use checklists. Thanks for the great talk. How to use checklists when you want to deploy a system or something, but do you think this should be used somehow in the way we do research, publishing papers? Like, should you be banned from submitting to a leaderboard if you fail the checklists? Is this something that we should consider?
Yeah, that's a good question. I think one way to integrate checklists with more of a research pipeline is essentially to think of leaderboards as having more than just a single number. right? So I don't know I'm not a UI person, but I could imagine a case where, yeah, sure, we still have numbers and accuracy is not useless, right? Like that's not my point. It is a useful first order signal, but then clicking on an accuracy should give you a breakdown in terms of known tests as to what the performance of these different models are. And people should be able to sort things according to fairness or according to temporal stuff and negation stuff if they want to see which models work across those, right? So in some sense, it's more fine-grained evaluation, not necessarily replacing quantitative evaluation, right?
Yeah. I want to like slightly push back on that, just because like today we had this discussion in our group about I don't know, like doing something like checklist for various semantic skills, we called them, and then like we remember, oh, but Glue had those. There was this diagnostic skill set, and like they did it, and for every submission you would get like this breakdown, but it was, I don't know, maybe, I don't know if it's true or false, but largely ignored in tracking the state of progress. So like somehow it's, I don't know, that's why I said maybe like ban submission or something if you don't test checklists. Like maybe we need to do something more extreme, or like it's very easy to measure stuff and then ignore it.
Yep. That's a good point. Yeah. And how to get community to, yeah, what are the mechanisms to help the community think a little bit more about this? Yeah, that's something definitely to think about, right? I think leaderboards make it easy to focus on a few numbers. And when you're doing research and you're building models, it's nice to have that single number that you're optimizing. And yeah, and how to move away from that is a bigger question. But hopefully this paper helps at least people think or appreciate when people do it, and therefore there'll be some effect here.
Thanks for the talk also. It was great.
Thanks.
There is a question by Jorg. Do we publish the checklist and should they be part of the leaderboard sites? Or does that create a danger of optimizing to pass the checklist without actually fixing the underlying problem?
Yeah, so this is a good question. And I think maybe I'll rephrase that a little bit, is sort of what if people start optimizing checklists, right? So one thing I think of checklist is not a static set of tests, and I don't imagine it'll ever be kind of static. I could expect you creating a set of tests that you think if a model passes, you are pretty reasonably confident that the model has solved the task, right? And so that suggests that you might change your mind and you can add more tests. But essentially, if the failure rate is close to zero on the set of things that you care about and the models seem to pass it, maybe at that point you are done and maybe the model has actually solved the task that you're doing. Of course, we're not anywhere close to that yet. But related to that, I also want to say that there is this temptation of, well, now that you have these tests, why can't we just put it in the training loss and just optimize it and get accurate on it? And that is something that we've been sort of pushing back on, partly because the test set, the checklist, we should almost think of it as an evaluation test set. And so you don't want to just take the test set and put it in the training to get better on the test set, right? That's definitely a no-no. And so for similar reasons, you don't want to just use these tests and put it in the training, because the strength of these tests, they're very simple. They're all templated. They are, they're not exactly how some user might say some of these things, but their value isn't being something that you're doing only at test time. And if you start putting it in the training data, then you've lost the value of those tests. You would have to come up with new ways of phrasing the same phenomena and trying to test that way.
I have a follow-up question on that. So, it makes perfect sense that you cannot just put your checklist on your training data because that's, defeats the purpose of the checklists. But, ultimately, these checklists exist because you want systems to be more robust to certain types of errors, right? So it seems natural that, there's something that should, we should have an usage for these that goes beyond just using them as diagnostic tools, right? How can we use the information that we obtain in these checklists to improve systems themselves? And, by doing that implicitly, we are not exactly putting the checklist in our training data, but we are kind of overfitting to the tests that we are doing. do you have any thoughts about how can we make this practical in system designing? I mean, how can we make this a process that leads us to build better and better systems?
Yeah, that's a good question. I think part of it is how you are solving the task, right? So if you are saying, hey, I need just more training data, and I'm going to get that from some source and then evaluate my new model on the checklist and it gets more accurate, that's a reasonable thing to do. But if you're going to say things like, oh, I need to look at every time a knot appears, I'm going to add a loss where every time a knot appears, I should do something differently, then maybe you're sort of fitting it to the checklist, right? So I think the answer sort of depends on where the solution is coming from. And it's difficult for me to say recommend a certain sort of style of fixing these bugs because the answer could come from anywhere, right? I do expect, I mean, this is sort of me putting on sort of the researcher hat, that some of these things are just going to come from better language modeling or better pre-training models, right? So right now, this mass language modeling is maybe it's just one loss. Maybe there are ways you can augment that loss during pre-training time that will have the appropriate effect at test time after fine-tuning. And there's been some work that has sort of added numeracy or added factuality into these pre-trained models that have shown to be useful even on downstream tasks. So I feel like more fundamental research is the answer to some of these things, but that's not a satisfactory answer in many cases, right? You want my model not to be racist. You don't want to sort of reinvent BERT or whatever just to fix that. Yeah.
Sorry, so Ido has his hand raised. Do you want to ask a question? You're muted.
You're muted.
Yeah, I can. Yeah. Hi, Samir. Thanks for the great talk. I mean, for the tests, so you said that for each task, you said this kind of the methodology should be that for each task, the developer should think of a suitable set of tests in the checklist that would, make the developer feel comfortable that the system, performs as expected. But then many of the types of tests you illustrated were related to quite generic language properties. So, that kind of have two sides of this question. I mean, do you think that the part that refers to generic properties can be pretty much standardized and kind of you can give a library of such tests? And related to that, I mean, did you notice that people, to solve some of this, so suppose I have a test for negation and I see that my system doesn't perform well. Okay, for that I have to find good solutions for negation, which the community doesn't offer yet, right? The state of the art doesn't offer yet. So do you think that these tests can push more generic research, not necessarily task-specific, to address these linguistic structures?
Yeah, so that's a good question. I think I'll answer the second part first. So yes, I think, my answer to Andre's question was also, you articulated it much better. I think a lot of these issues will get fixed across tasks, and hopefully this will encourage more research into how to create representations of language that know about negation and know about temporal in a way that's not just task specific, right? So I guess I hope this would encourage not someone to create a data set of temporal QA and then just show that models can train on that data set and get high numbers. I would much prefer if this inspires work that says, okay, here's a way of injecting temporal stuff into your representation such that for all the tasks that have temporal issues in them get fixed. And in some sense, checklist is providing already 3 or 4 tasks that have temporal slices, even though otherwise nobody would have thought of evaluating temporal stuff of sentiment, right? Or of question pair detection, right? So that's a good point. To the first point, I think that's a very interesting thing that we've sort of been struggling with right now. So good insight there, where clearly there are certain things that, like negation, that completely generalize across different tasks. And you want to make sure your models know about that. And there are some other ones where the way they come up look very different. So for example, for named entities, in sentiment, the sentiment should not depend on named entities, but in question answering, clearly the named entity is the whole point of your question, so it should matter, right? So for checklists so far, we had been mostly focusing on providing the set of tools so that you can say, hey, I want to do something with named entities. And we give you the tools to allow you to specify for your task what's kind of useful. But I think going forward, we are thinking of saying, okay, here are definitely the sort of things you should be thinking about. And here are almost like more of a recommended set of capabilities and tests that you might want to adapt to your specific application. And we are moving a little bit more towards that. So yeah, that's kind of close to what you said as the first recommendation. So for example, if you're thinking, if you care about fairness, here are the different ways you might, these are the sort of different perspectives that we have come across or the community has thought about and papers have already thought about that might be applicable to you. And here are sort of how they show up in your data set, for example. So yeah, that's definitely something we're thinking a lot about.
Okay, thanks.
Right. Thank you very much, Samir, for the great talk. So this was a very interesting discussion, but in the interest of time, we need to finish and move on to the closing session.
Thanks, everyone.
Right.